Hey there, Tech Guild fam. Welcome back to another mind-blowing episode on our channel. So, what's the plan for today's video? Well, we're gonna start off with a quick rundown on what this whole neuromorphic computing thing is all about. We'll also take a sneak peek at some real-life applications that are already using neuromorphic computing. It's not just future stuff, it's happening right now. And of course, we'll chat about the challenges and limitations too. So, are you ready to dive in? Because we're about to embark on a thrilling tech adventure. AI, as we know it today, is a game changer. It's massive, powerful, and it's everywhere. From large language models like GPT-3 with its billions of parameters to AI tools meeting and beating benchmarks, AI has been making waves in every industry. But it's not all sunshine and rainbows, folks. Despite its mind-blowing capabilities, AI today faces some serious challenges. With great power comes, well, a huge energy bill. Take GPT-3, for example, its carbon emissions were through the roof. Just imagine, the energy consumed to train it could power the average American home for, get this, 41 years. That's a whole lot of Netflix binges, my friends. Plus, with AI's growth, we've seen a surge in reported issues like misuse of AI and privacy concerns. Imagine AI tech being used to track gang members or even scan and determine the emotional states of students in a classroom. And though corporate investment in AI dipped in 2022, the number has increased 13-fold in the last decade. So, we're still seeing mega investments like Microsoft's $19.7 billion acquisition of Nuance Communications. So, you might be thinking, where do we go from here? Well, what if we could develop AI that mimics the human brain more closely? Could we reduce the energy usage, make AI more efficient, and potentially address some of these challenges? That's where neuromorphic computing comes in, my friends. This cutting-edge field is taking us beyond today's deep learning algorithms and bringing us a step closer to adaptive AI. It's happening right now, with companies like Intel leading the way with their next-gen neuromorphic research chips, boasting up to 10 times faster processing capability and 60 times more inter-chip bandwidth. This innovative approach is already finding applications in areas like sensing, robotics, healthcare, and large-scale AI applications. Alright, let's get into it. What exactly is this neuromorphic computing we've been talking about? Well, imagine if we could build a computer that works not like your typical desktop or laptop, but like a human brain. Neuromorphic computing is this super rad field of technology that uses the principles of biological neural computation, or in simple terms, it tries to mimic how our brains work. It uses these new algorithmic approaches to emulate how our brains interact with the world, aiming to bring AI capabilities closer to human cognition. It's not just about making calculations faster. It's about making them smarter and more intuitive. Traditional computers process information in a sequential manner, one task at a time, one after the other. But our brains? They're a whole different ballgame. They process information in parallel, meaning they can do multiple things at once. Neuromorphic computing aims to bring this parallel processing power to computers. It uses something called spiking neural networks, which are these novel models that simulate natural learning by dynamically remapping neural networks. It's like they're making decisions in response to learned patterns over time, kinda like us humans do. This approach allows neuromorphic processors to achieve massive gains in power and performance over conventional architectures. And the potential advantages? Oh, they're enormous. Neuromorphic computing could power future AI solutions that need energy efficiency and continuous learning. It's like turning AI from a one-trick pony into a multi-talented superstar that can sing, dance, and act, all while using less energy. This tech is already being used in areas like sensing, robotics, healthcare, and large-scale AI applications, and the possibilities are only expanding. Alright, Tech Guild fam. Get ready to have your minds blown as we dive into the real-world applications of neuromorphic computing. This isn't just theoretical stuff we're talking about, it's already making waves in the field of AI. One of the industries excited about the potential of neuromorphic computing is the business sector. According to a PwC survey, nearly half of global CEOs believe AI will significantly change the way they do business over the next 5 years. They're not just sitting around waiting for it, they're investing in the development and implementation of AI technologies like neuromorphic computing. But let's get more concrete, shall we? Neuromorphic computing is actually already in use today in a few awesome ways. For instance, have you ever thought about how we can make our cities smarter and more efficient? Well, Intel's Loihi chip, a neuromorphic processor, has been used for intelligent traffic light control, helping to reduce congestion and make our commutes smoother. It uses real-time data and makes quick decisions just like our human brain would in a similar situation. But that's not all, folks. Autonomous vehicles are also taking advantage of this tech. Intel's Loihi has been used in autonomous vehicle systems to help cars interact with their environment in real time. Picture this. Cars that think like humans, making split-second decisions to ensure safety. Well, we've seen that our current AI models are getting bigger, pricier, and, let's face it, they're not exactly great for the environment. But here's where neuromorphic computing comes in. It promises to give us AI solutions that are not only more efficient but also better at continuous learning. That's like your little brother, who doesn't stop asking questions, but in a computer chip. Neuromorphic computing is all about emulating the way our brain works. It uses something called spiking neural networks, SNNs, to learn and make decisions over time, just like we do. Imagine having a brain-like computer that can sense, learn, and adapt on its own. It's already being used in various areas like robotics, healthcare, and even large-scale AI applications. The experts believe that in the future, this could totally transform the AI landscape. Imagine your smart speaker not just playing your favorite songs, but actually understanding your moods and suggesting songs that fit your vibe. But hey, this is still a growing field and there's a lot more to discover. Now, the first thing that might pop into your head is, hey, isn't this stuff going to be crazy expensive? And you'd be totally right. We're seeing a big trend where these large language models, like the ones used in AI, are getting bigger and pricier. For example, there's this one model called Palm that launched with 540 billion parameters and cost a whopping $8 million to train. So yeah, costs are definitely a big hurdle to get over. But it's not just about the money. They burn through a ton of power, which leads to big carbon emissions. In fact, one model called GPT-3 was a serious carbon emitter. So, we've got to figure out how to make these models more green if we want to keep our planet chill. On top of all that, there are some techie issues to deal with too. Like, these models are becoming so good at what they do that they're outgrowing our current benchmarks. Basically, they need more challenging tests to really see what they're capable of. It's impressive, but also a bit of a problem. Now, let's talk about neuromorphic computing specifically, cause that's our main jam here. Companies like Intel are making huge strides with chips like Loihi 2. These chips are way faster and can handle way more information, but they're also a big step into the unknown. We're talking about a whole new way of computing here, so there are bound to be some teething problems along the way. Challenges are just opportunities in disguise, right? We've got smart peeps all over the world working on this stuff. And the potential benefits are seriously mind-blowing. We're talking about computers that can learn and adapt like humans, helping out in areas like healthcare and robotics. So yeah, it's a tough road, but the destination is totally worth it. Alright, my dudes and dudettes, it's time to wrap up this wild ride. We've been talking about neuromorphic computing. That's like the next level of AI. It's inspired by our own gnarly brains and it's all about making decisions and learning just like we do. We've also surfed the challenges, from being in the research phase to needing some serious cash and energy to power these things. But remember, every challenge is just a big wave waiting to be ridden. So, what's the takeaway? Neuromorphic computing is the future, dudes. It's gonna change the way we live, work, and even how we catch waves. But like any gnarly ride, it's got its share of wipeouts and shark encounters. But hey, that's what makes it so exciting, right? Now, if you found this video as rad as a perfect wave, go ahead and share it with your friends. Let's spread the stoke and get everyone on board with this neuromorphic computing thing. And if you want to keep up with the latest in tech, don't forget to hit that subscribe button. You'll be the first to know when we drop a new video. Alright, my friends, that's all for now. Keep shredding, keep learning, and stay curious. Can't wait to catch you on the next wave. Stay stoked, dudes and dudettes.